Hello, lovelies. You're welcome to the second class of this term. My name is Brownlee Obrutu. I'll be teaching you a very important concept in mathematics. In the last module, you learned about whole numbers. In this video, you will learn about indices and standard form. If I ask you what are indices, do you have an idea? I can see you're thinking about what indices are, but let me define what indices are to you. Indices are powers of numbers. Take a look at this number. 3 here is the power of this number, which is also called the index. The singular form of indices is index. So index is also the same thing as indices. 5 here is the base. 5 raised to power 3 is the short form of writing 5 times 5 times 5. When solving problems involving indices, there are laws. We call them the laws of indices. The first law is the multiplication law. Do you know that we can multiply two numbers by adding their powers and then picking one of the base? For example, 10 raised to power 2 times 10 raised to power 3 can be multiplied by adding 2 and 3 and then picking one of the base, which is 10. 2 plus 3 equals 5, and then if we pick one of the base, we would have 10 raised to power 5. Why is this so? By expansion, 10 raised to power 2 is 10 times 10, and 10 raised to power 3 is 10 times 10 times 10. 10 times 10 times 10 times 10 times 10 in short can be written as 10 raised to power 5. Did you observe something? The results by expansion and the result we got by adding the powers are the same. Anytime you have the same base multiplying themselves, simply pick one of the base and add the powers. Simple, right? So the multiplication law makes multiplying large numbers pretty simple. If we were to simplify 10 raised to power 27 times 10 raised to power 23 by expansion, it would be really difficult writing 10 times 10 times 10 times 10 into 27 places and then also doing that for 10 raised to power 23. But we can use the multiplication law to solve this. How? Pick one of the base and add the powers. So we would have 10 raised to power 27 plus 23. 27 plus 23 is 50. So the required answer will be 10 raised to power 50. Now, if I ask you to multiply y raised to power 10 times y raised to power 7, can you do this? Of course. We have a common base to 10 and 7. So we'll pick one of the base, which is y, and then add the powers. So we'll have y raised to power 10 plus 7, and 10 plus 7 is 17. So the required answer is y raised to power 17. Take a look at another example on the multiplication law. 3c raised to power 2 times 2c raised to power 5. First, we multiply the numbers. So we'll have 3 times 2. Next, we pick one of the base, which is c, and we add the powers, which are 2 plus 5. Next, we multiply the numbers, which is 3 times 2, and then we add the powers, which is 2 plus 5. So we would have 6c raised to power 7. This is the required answer for this problem. I hope you understand this. Let's go ahead to look at another law, the division law. This law states that when you have the same base dividing themselves, simply pick one of the base and minus their powers. Take a look at this example. 12y raised to power 7 divided by 4y raised to power 3. First, we divide the numbers 12 divided by 4. And since we have the same base here, we pick one of the base, which is y. The rule states that when you have the same base, simply pick one of the base and minus their powers. Next, we minus the powers, so we have 7 minus 3. 7 minus 3 is 4, and 12 divided by 4 is 3. So our answer will be 3y raised to power 4. I hope you understand this. The next laws we'll be discussing are the zero and negative powers. Any number raised to 0 is equal to 1. So y raised to power 0 is equal to 1. Similarly, 10 raised to power 0 is equal to 1. So any number that is raised to power 0 or alphabet raised to power of 0 is equal to 1. This is known as the zero law in indices. We also have the negative power law. If you have a negative power, such as we have here in c raised to power minus 1, you clear the minus sign by using 1 all over to represent the minus sign. And if you take out the minus sign, what will be left? It's c raised to power 1. C raised to power 1 is the same thing as c. Anything raised to power 1 is that same thing. So c raised to power minus 1 is the same thing as 1 all over c. Did you get this law? Anytime you have a negative power, replace that negative with 1 all over and put what is left off at the denominator. Take a look at this example. 3 raised to power minus 2. So I told you about the negative power law, that when you have a negative power, you replace that negative power with 1 all over. And what will be left here, if we take out the minus, what will be left is 3 raised to power 2. So we'll put it at the denominator. 3 raised to power 2 is the same thing as 3 times 3. And 3 times 3 is 9. So we'll have 1 over 9. This is the required answer. Take a look at this example. Simplify this expression. X raised to power 0 times x raised to power 4 times x raised to power minus 2. We have a combination of the zero power law and the negative power law here. Now remember that anything raised to power 0 is 1. So x raised to power 0 is equal to 1. And then we have times x raised to power 4. I told you that when you have the negative power, you replace the negative power with 1 all over and then you put what is left off as the denominator. So x raised to power minus 2 will be 1 all over x raised to power 2. We can multiply 1 times x raised to power 4 times 1. Anything times 1 is that same thing. So 1 times x raised to power 4 times 1 is equal to x raised to power 4 over x raised to power 2. X raised to power 2 can go into x raised to power 4. If we divide x raised to power 4 by x raised to power 2, we would have x raised to power 2. This is the required answer. Let's now move on to standard forms. It is easy to express numbers like 1,000, 1 million, 1 billion as powers of 10. For example, 1 million is equal to 10 times 10 times 10 times 10 times 10 times 10. We multiplied 10 6 times because we have 6 zeros in 1 million. And the short form of writing 10 times 10 times 10 times 10 times 10 times 10 is 10 raised to power 6. So 1 million can be expressed as 10 raised to power 6. We can also express any number as a product of two terms. For example, 2 million is equal to 2 times 1 million. Remember that 1 million is the same thing as 10 raised to power 6. So we would have 2 times 10 raised to power 6. This form here is called standard form. I hope you got this. If you're asked to express 480 million in standard form, this is how you do it. 418 million is the same thing as 4.8 times 100 million. And 100 million can be expressed in short as 10 raised to power 8. This is the required solution. We can also express numbers that are less than 1 in standard form. Decimal fractions such as 0.001 and 0.000001 can be expressed as powers of 10. For example, 0.000001 can be written as fraction as 1 all over 1 million. It is 1 million because we have 6 zeros in 0.000001 and 1 million. And 1 million can be written in short as 10 raised to power 6. So This will be equal to 1 all over 10 raised to power 6. We can express this in standard form by taking the numerator, which is 1, and multiplying it by 10 raised to power minus 6. Take a look at this example. Express 0.075 in standard form. First, let's put 0.075 in fraction. This will be 7.5 over 100. Did you see that the decimal is after the first significant figure, which is 7? And also, we have 100 because we have 2 zeros in 0.075. In short, 100 can be written as 10 raised to power 2, so we would have 7.5 over 10 raised to power 2. To write this in standard form, we'll pick the numerator, which is 7.5, and then multiply it by 10 raised to power minus 2. So we'll have 7.5 times 10 raised to power minus 2 as the required answer. We have come to the end of this video. Answer the evaluation questions underneath this video on your notebook. See you!